Hey everyone, it is Mrs. Buchholz here. I am here to teach you today about something called a hydrate. And if we were to give a learning target for what we're learning today, is we're going to learn what a hydrate is and how to write names and formulas for hydrates. So let's get started first of all with just a definition of what a hydrate is. If you look at the word hydrate, a portion of that word is the word that sounds a lot like water. You know, hydration means water. Hydraulics has to do with water. And so hydrates are specific compounds that have water with them. And so if we write down a definition of it that you're going to want to write down in your notes, we would write down that it is a compound that has water, but specifically it's absorbed water. So you know that our air is not completely dry. And so compounds that are hydrates are compounds that have absorbed water from the air. We're going to say it a little bit more technically correct. So they absorbed water molecules from its environment and have those water molecules included in their structure. Now, we haven't learned yet about bonding and about drawing structures for compounds. But the big thing you need to understand here for hydrates is just hydrates are compounds. We've dealt with compounds all year, and they're compounds that have water molecules kind of loosely attached. So let me give you an example. Copper sulfate. Copper 2 sulfate is CuSO4, is a common compound that if I let it sit out is going to naturally absorb water from the air. Now, it's always going to absorb 5 water molecules. Now, the way we show a hydrate when we're drawing its formula is we draw first the actual chemical. So that's the chemical formula that we're going to write just like we would have from previous chapters. And then afterwards, we're going to write the waters. Now, if you notice, the other thing that I have here that makes it pretty easy for us to see that the waters are attached is this little dot. So the dot basically shows that the water molecules is attached to the copper sulfate. Okay, so we show it with that dot. The other thing you're going to notice is the number 5. So that number 5 tells us how many water molecules are attached. So this compound that's a hydrate is copper sulfate pentahydrate. Penta comes from the number 5. So what we're going to talk about is how we write names and formulas for hydrates. So we're always going to have the dot. We're always going to have the chemical formula first. Again, I've got that in green here. And then we're going to have the waters afterwards. And we're going to tell how many waters there are with a number out front. The number of waters is going to be different for every chemical that's a hydrate. All right, so as far as naming this one, let's go ahead and write the name of this compound. I'm going to go ahead and erase this over here. And the way we name a hydrate is we first name the chemical, just like we would have in previous chapters. This is copper, Roman numeral 2 because it's a variable charge ion, sulfate. And then we use a prefix to tell how many waters. The prefix for 5 is penta. So it's penta, and then we use the word hydrate. Penta tells me that there are 5, and then the hydrate tells me that that's the waters that are attached. So let's do a couple examples of that. So another example might be this one. MgCl2 dot 7H2O. So let's write the name for that compound. MgCl2.7H2O. So Mg and Cl2, again, you could look at your ion sheet if you needed to, but that's magnesium chloride. And again, I use a prefix to tell how many waters. The prefix for 7 is hepta. Heptahydrate. And that's how we name hydrates. Again, we name the compound using the ion sheet, magnesium chloride, and then we use a prefix to tell how many waters there are. Again, in this case, hepta means 7. Now, if you need a quick refresher on what the prefixes are, I'm going to write those down right now. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So again, we use these prefixes to tell how many waters are attached in that hydrate. I'm going to do one more example of writing the name and then a couple of going backwards and writing the formulas. So the last example of me writing the name, BeSO3.4H2O. So I start by naming the chemical, what I'm underlining in green. I would use my ion sheet. Be is beryllium. SO3 is sulfite. And now to name the hydrate part, I look at how many waters there are. There are 4, so it's tetra. And again, the word hydrate to show that there are that many waters attached. That's how we name a hydrate. To go backwards, it's fairly straightforward. Okay, so if I were to give you this name, cobalt 2 chloride hexahydrate, and asked you to write the name, this is what you would write. So I start with the chemical, and it's ionic. I'm going to check my charges. Cobalt is CO plus 2. Chloride is Cl negative 1. And so that formula becomes CO Cl2. I put a dot to show that it's a hydrate. And the hexa means, if I look back at my prefixes, 6. 6 waters are going to be attached. 6 H2O. One more of those. So let's say I had calcium, fluoride, trihydrate. So again, we're going to start with the chemical, not the hydrate, and we check our charges. So on my ion sheet, I would see that calcium is plus 2, fluoride is negative 1, so that is CaF2. And now I look at the hydrate part. Tri means 3, 3 waters, dot, 3 waters. All right, so at this point you should feel comfortable knowing what a hydrate is. Again, it is a chemical that has waters bonded as part of its structure, and you should know how to write both the names and formulas of hydrates. The next thing you're going to be talking about is how we can separate a hydrate. It's kind of cool. To separate a hydrate, if I want to take this copper sulfate that I had at the very beginning of the lesson, and I wanted to separate it out, all we have to do is add heat. When I add heat to a hydrate, the water is what's called driven off. And what's going to happen is you're going to be left with copper sulfate that's called an anhydrate, hydrate, or something that's been dehydrated. So again, if I want to get the water out of a hydrate, I simply heat it up. When I heat it, the water goes away, it's driven off, and I'm left with just the chemical, no water. And this is called an anhydrate, which means it doesn't have any water. Or sometimes we call it dehydrated. We took the water away. And I just want to show you a quick example of what that looks like. So the picture right here, this is copper sulfate pentahydrate. When I heat up copper sulfate in a test tube and the water is driven off, this is what the copper sulfate looks like. So it actually changes its physical properties. It's also going to decrease in mass because I've somehow gotten rid of the water. All right, I hope you've understood both what a hydrate is and how to write names and formulas for hydrates using the prefixes we've learned before in this class. Good luck working, and thanks for listening.